Hello there once again. Alright, so what I've discovered, hold on, let me, if you hear a noise talking in the background, as I mentioned in a previous video, my girlfriend is a teacher. She's teaching from home. Doesn't matter how many doors you close, you know, her voice carries, what can I say. Alright, anyway, so one thing I do remember about black screen CD32s is that there's an issue with the reset line. There's a voltage detector that keeps the reset line active low, I believe it is. The schematics, well anyway, so I mean this has been reported by a couple of people on the internet. Somebody posted a link in the comments of a previous video on this series about the fact that the voltage detector can go bad and won't output clean 5 volts anymore. You know, I'm thinking the reset line like to the chips. Well, actually no, it's the reset line for the keyboard actually. So, because I was looking on the schematic, he provided a little snippet of a schematic for the voltage divider, and it's, you know, I looked that up in the schematic where U14. This is just the keyboard, really. It's for the keyboard. I don't see any connection to any the actual reset line of the board. You know, it's only the keyboard reset. So, which will make the computer, if it thinks that you're always holding down those keys, it's never going to boot up. So, you know, even though there's no keyboard, you know, I have plugged into the CD32. So, you know, looking for U14, we're not going to look in, you know, around this area of the board where you'd think that a reset line active low signal would be manipulated or whatever. You're going to go over to the keyboard connector, and U14 is literally right next to the keyboard connector. I'll throw images up on the screen and give the link or whatever to both sites I went to. Yeah, so actually both links come from tsb.space, and the first one, the only one that I'd ever seen, is that somebody says problem solution, you know, and not very specific. You know, I mean, if you go and you test and you notice that the main reset line is fine, it's not being kept low or whatever, then it wouldn't necessarily cause you to look at the keyboard reset line. Basically, the keyboard reset is also linked directly to the button. There's a reset button on the top of the CD32. Let's bring that over and show you. So there's a reset button on the CD32 right there next to the door, between the door and the power switch. So that reset button and the keyboard reset signal are linked directly together. This schematic is directly linked to the keyboard, and then you know, on the right side of it, and then to the left side of it, it goes to what's called active low button, and that goes straight to the reset button. So anyway, what's happening is it has a failure in it, and it's not passing all of the 5 volts through. It's only passing a bit of it. And according to the gentleman at TSB, it's supposed to have a threshold of 4.3 volts at least, and it's not. So the reason why I have this all set up like this is because I want to show you the test. But anyway, let's find out if this is indeed our problem. So let's see. So Tweedle Dee is the one that works with diagrams, so there's no way that the reset keyboard / button reset is being held on by the voltage detector. So there isn't a need or reason to even investigate that one for that reason, for that purpose, because, you know, doesn't have that problem. And then I have to, because this switch is goofy, I have to test the voltage on the stupid thing. Just to make sure we're getting 5 volts, because that switch is intermittent. Come on. Alright, so the power rail's on the bottom here, and 1268 volts and 5.1. Okay. Alright, so here it is, moment of truth. So here, got 5 volts coming into it as far as I know. 5 volts. And what do we got coming out? 5 volts. Sorry guys. That's not our problem. That's not our problem. Anyway, for those curious about whether it was the voltage detector, and there's a gentleman on this tsb.space website who says, "Oh yeah, we've had a lot of them." Of course, we knew it wouldn't be that easy, right? Come on, guys. We knew. I mean, this is Retro Friends. We don't have easy fixes here. You know. Of course, I'm gonna. My next step, I believe, is to replace the caps on Tweedle Dee. I'm still not 100% sure of that. I do have more caps coming. I have one complete cap kit for the CD32, and then I have another set of caps coming. The only ones I could get in a short period of time. I'm kind of impatient at this point. But it looks like Tweedle Dee is probably a good candidate for the recap, like I was saying earlier. And yeah, that's probably going to be my next step. Okay, I have an update. I've been using an oscilloscope, a Siglent oscilloscope here. Used it in some of my other videos. And there's test points all around. See, I got the extra lens on here. I just need to make sure that I'm close enough. Let me turn this board off so that nothing gets shorted or whatever. Alright, so that's probably good right there. Okay, so and I'll use my oscilloscope probe to point with. So we have various test points, and each of them are, what, 10 points? So here's TP3, TP4, TP2, TP1. So if you ever use the test points, I suggest printing out this page of the schematics, because it lists the test points. And the first 4, well, the 5th one is also important. I'll throw it up on the screen, but we've got all the major signals on here, even some samples. For example, TP1 has the address bus, the first 2 channels of the address bus, and TP2 has the last 3, if I'm not mistaken. Well, 21, 22, and 23, the signals. And so basically this is Tweedle Dee. What Tweedle Dee is doing is it's attempting to start, but it's issuing, I mean, it possibly could be issuing a reset. What it's doing on the oscilloscope is reset is an active low. So when it goes low, it means that there is a reset happening. But it's always high, right? But then you see a little flash on the oscilloscope. And I've tried to adjust the timing, but it's like happening every 5 seconds or something like that. It's very infrequent. However, everything else is happening like once a second. Like the rest of the resetting of Tweedle Dee, you know, where everything is like cycling and trying again or whatever, is happening like once a second, much more frequent than that, which is odd. Meanwhile, the power light is a steady bright. Now, So what I'm having is, I checked all the clock signals that I could find. I believe that there are. They're either 28, 14, or 7 megahertz, depending upon, and that's coming from the primary clock source, the primary crystal, which is here, which is a 28 megahertz crystal, but it's split, and then it's split again for various different things. So Alice is providing the clock for the CPU, but that's all good. All the clocks are good. Actually, Alice is providing the clock for Akiko as well, and that, as far as I can tell, is good. It's kind of narrowing down to Akiko because I have notes here. The address lines that I tested, A0, A1, and A21 to 23, are resetting on that thing. You know, there's a signal on them, and then they reset. Then there's RW, read write, and those are all resetting. So all of these signals, and let's see, I think it's happening on RGA, and actually no, RGA is fine. The one bus on this Tweedle Dee that is not being affected, which is just a steady on, is RGA, the register address. And guess what chip doesn't have a connection to the RGA? Akiko. So Akiko doesn't have anything to do with the RGA. RGA is between Lisa, Alice, and Paula only, as far as I could determine from the paths on the schematic. So registers are only being passed from Alice to Lisa to Paula. Yeah. So I also checked the RAM enable, and the RAM enable is not working. It's not, I mean, among everything else, but the RAM and on the schematic itself, it doesn't show where that's coming from. It has Akiko and Alice right next to each other, and the RAM enable is connected together, and then there's a pin that comes out from that, but it's like an input. It's like an input pin. I wonder if that's because, no, I don't think RAM enable is on the edge connector. It's not coming up that way on the schematic on the Amiga PCB Explorer. It's only saying that it's going to 3 places. Going to Akiko, Alice, and a test point. And the test point is there on TP3. It's the 3rd pin. So where's the signal coming from? It's showing that it's coming in on a pin and then being split between Alice and Akiko. So that's a kind of a fail on the schematic, because there's only 2 chips that have it, Akiko and Alice, and one of them has to be initiating it. You know, it's not a two-way signal like a data bus. It's going to be enabled by something. And I looked and I found a pin out of Alice, but it doesn't show if that pin is an input and output. However, I went to Akiko. In the CD32 service manual, Akiko has pinouts, and I looked at pin 71, the RAM, and it's an output. So Akiko, again, we're talking about Akiko sending the signal for RAM enable. I wrote this wrong here. RAM enable. Actually, let's see where ROM enable is coming from. ROM enable is coming from Akiko as well. So ROM enable from Akiko. So this proves that Tweedle Dee isn't working because Akiko is not letting it work. Now, there's nothing there's no document on the internet or that anybody could find, that I could find, as far as what would cause Akiko to not want to turn the computer on, to not finish turning the computer on. Akiko could be broken, of course, right? But what sort of thing else could be causing, let me see, there's also the reset line, and the reset line is a two-way street. Let me just look at Akiko's pin 159 on Akiko. 159 reset is a B, a bidirectional. Yeah. So Akiko, the reset on Akiko is bidirect. See, you could figure some of this stuff out if you lifted a pin, the pin in question, off of one of the chips, but good luck on these frickin' chips, you know? I mean, geez. I guess you could, I guess you could lift the pin. It would be very sketchy, especially on Akiko, who has frickin' tiny pins. The processor and Akiko are both are going to be the most difficult chips to replace and do any kind of diagnosis on out of circuit. So the reset line is bidirectional on Akiko, and on the 68,000, I don't know, but whatever. The fact that it's bidirectional, it basically doesn't tell us anything. Alice, the schematic I have for Alice, or the pinout of Alice, doesn't give any signal path direction. So that's not helpful. But anyway, what I need to look into is what would make Akiko, if Akiko was working, what would make Akiko not work? Would it be the processor is dead, or would it be that, let's see, what does Akiko have? It can't be the register address bus, because it's working and it's not connected to Akiko. It's a constant pulse. It's like there's two constant pulses on this board. Anything having to do with the clock and the register address bus. But Akiko is connected to the, well, it does address the chip mem, or it's logic for the addressing of the chip mem from Alice or something like that, and there's a DRAM address bus that Akiko has just a couple of points going to, but let's see, DRAM address bus, DRA, it's just, right, it's just signal 0 and 1, the first two signals from the DRAM address bus is going into Akiko, and the DRAM address bus obviously is an output of Alice. Well, my camera stopped, and I don't know, but basically I've found a couple things I'm going to look at. The one that's most interesting is there is a CPU space cycle that's an input for Akiko that's coming from the CPU. That might be Akiko figuring out if the CPU is working. So let's see what kind of activity. That's what I want to see. I want to see inputs. I want to look at all of the inputs into Akiko and find out. And then there's also the DRAM address, the DRAM address bus. Just the first two signals are coming from Alice into Akiko, and maybe if Akiko doesn't receive that information, it won't start, or maybe if the CPU doesn't see if Akiko doesn't see the first two signals of the DRAM bus, maybe it won't start, or maybe if Akiko does not see an input from the CPU space cycle, it won't start. So I'm going to look at those two things next. I think we may have a direction here. I went ahead and tested the what's known on the Akiko is the CPU space cycle, but what's known on the processor as a CPU output function code bus. There's only 3 signals on it. The odd part is that 0 So, you know, 3 signals, that's going to be 0, 1, and 2. So those 3 wires coming out of the CPU. The first one, FC0, is pulled up to VCC. FC1 is pulled down and FC2 is pulled up. So, and they run through one of the logic chips, U37, which frankly has a lot of stuff going on with it. That chip is really being used. So if I test FC0, and let's see if we can let's see if we can arrange this so you can actually see what I'm doing. Now, U37 on the schematic, right next to Akiko in the schematic, just to the left of it, right below all the address lines. U37 going into pin 1, it goes into pin 158, and it is an input according to the paperwork, Akiko. So it is an input from the CPU to Akiko. And so that on Akiko is known as the CPU space cycle, pin 158. And that is coming out of U37 pin 11. So this is a 14-pin chip. 1 is over here. So we got 7 here, 8, 9, 10, 11. If I can get a good knock on there. It's not going through a resistor or anything. 8, 9, 10. That's the 4th one over. Okay, so you can see, can you see? Yeah, you can see that it's high, but once in a while it'll jump down a little bit. But it's basically stuck high. This is an active low. This is an active low on a working motherboard. In fact, let's just show you that. Here's the good motherboard. And we want to get onto, I know there's a ground here, pin 11. See, we have a signal there on a working motherboard. And then the next 2 pins are the inputs. That's one of the inputs from the CPU, and that's another input from the CPU. So on a working motherboard, all 3 of those have a signal on them. The bad motherboard has a bad signal going into Akiko from the logic. But what about the input of the logic? Let's check this one. That's pin 12. And pin 12 is stuck high. Pin 12 is signal 0, and it's got a pull-up on it. Screensaver. 1, 8, 9, 10, 11, 12. Yeah, so this is going into Akiko. This is going into the logic chip from the processor. And that is after it's going through a pull-up resistor. So it's stuck high, it's getting nothing. It's getting nothing from the processor. And then this one here is FC1, which is pulled down, and it's stuck down. So basically on the FC bus, we're not getting anything. That's just the that's actually only 2 of the 3. So I don't know what the other FC function code path, I don't really see anywhere where it would go. I'm just looking at the schematic. I mean, it shows it being a 2-way signal, but that's going to the pull up and pull down resistors, and also going to the expansion connector, you know. So yeah, you know, the processor could be, this is another one of those things where we had a Kiko, where we had two wires being joined together next to two chips, and then when you see the signal going off the page, it's in a direction that doesn't make any sense, because actually one of these is going to be the source. So then what we'd want to do, I mean, because there wouldn't be any other source. You know, the pull-up resistors, and it's a good thing we have a good working motherboard, because we know that there's supposed to be a signal on there. And it's not like pull-up or pull-down resistors are going to create a signal. And the only other place it's connected to is the expansion connector. So that, and a Kiko is listed as that pin being an input. So the only source of output is the 020 processor. So now we've gone from the Akiko the Akiko to the processor. And now we need to figure out why maybe the processor isn't starting up. And so I'm going to do the same thing I did with Akiko, where I'm going to look at any inputs or whatever. But as far as I know, the processor is not supposed to do that kind of thing. I think Akiko is supposed to figure out if everything's working and start the machine. I mean, otherwise, why would you put the LED coming straight out of Akiko? It's an inverse signal, but it comes directly from Akiko, the LED. And Akiko seems to be the one that actually starts the computer. You know, it's not allowing the computer to start right now because it's not getting a signal from the processor. So the processor is either bad, or, I know I've tested the clock signal, it's fine, or something is causing the processor to not want to start. So I'm going to be going on from there to see. And so what's nice is that I'm pretty sure that Akiko is working. I mean, unless there's more than one thing wrong with the board. If there's only one thing wrong with the board, I think Akiko is actually working. Using the block diagram for, you probably can't see that, but you know, there's a block diagram for the CD32. I updated it and put it on my website, retrofriends.com. To actually, I put it on there because I wanted to show signal paths and signal names and stuff like that. I even have a legend that shows you, you know, describes which one it is. So the only connection that the CPU has to the buses is the processor address bus and the processor data bus. And you know, I mean, I guess if Alice or something, or Akiko is holding down the address bus for whatever reason, or one of the logic chips is, or the ROM. Of course, we've switched out ROM, so we know, I mean, unless there's a short somewhere. That's the one thing I haven't really gone into detail or looked at, is there a short or an open, you know, broken trace or crack or something, or is there a component, a smaller discrete component, like a resistor or capacitor or diode or something, that actually it has a problem. So that's why you say, you don't necessarily say that, oh, it's definitely the processor, because maybe the processor, maybe I haven't measured I think I did measure voltage on the processor on one pin, but now it's time to measure the voltage on the processor on all its pins, because the processor has multiple pins that have VCC on them and an input of power. So yeah. So we just need to look at the processor in detail, but maybe what we're looking at is a bad 68EC20, you know. Maybe that's what we're looking at on this one. And I haven't even gone that far into Tweedledum to know what that is, but I figured, you know, this one has got a real major problem. It just, nothing works, you know. Absolutely nothing. Diagram won't even go. And you know, what is required for diagram to work? It needs to have a processor. It needs to actually have I'm trying to think, like, I'm pretty sure that the chip mem Alice, you know, that could be dead. But if Akiko's dead or the processor's dead, a diagram's not going to work. It's not going to boot up. It's got nothing to process it. Akiko, it starts the computer up, as far as I can tell. Yeah, these two are very tightly. I mean, Akiko is really important. It's the Gary of this particular computer. It's the gate array and does CD controls and everything. It's like everything. So I guess if I really don't get anywhere, I guess I'll just try to replace the 020 processor and see if that helps. But I just, you know what, maybe what we should do, excuse me, is we should see what our fortune says about all this. Maybe this will tell us which direction to go in. Today is an opportunity to begin again. What does that mean? That's actually not that, you know, should I begin again? Should I restart? Maybe I should drop this board for now and go on to the other one. Today is an opportunity to begin again.